Okay, today we're going to take notes on the order of operation. It's our lesson 1.1. So first we need to know what are the order of operations and why do we need them. The order of operations are as follows. We start out with parentheses, and this includes all brackets in problems. And you always want to start with the innermost grouping symbol. Next up, we look at and evaluate exponents. This also includes roots, so square roots, cube roots, things like that. So I'll put that as well. Next up, we have multiplication and division. And even though the multiplication comes first, they have to be done left or right. So sometimes division is first. I'll abbreviate. And then I'll put here that it's left to right. Addition, subtraction works the same way. We want to do them in order left to right that they appear in the problem. Okay, so you can see the letters do spell out the PEMDAS. Okay, let's do our first example. If we look at this problem, 9 minus 14 times 3 divided by 7. We'll go left to right. There are no parentheses. So we'll go ahead and look at the first thing up, which is the multiplication. Actually, let's do this example instead. So when we look at this problem with several sets of grouping symbols, the brackets and the parentheses, we want to go to the innermost one first. So the first thing we want to simplify is right here, the 12 minus 7. So a lot of times these problems take up a lot of writing because we have to rewrite the problem. So 2.5 plus, and then we'll keep this 3. 3 next to the parentheses indicates multiplication. So we simplify inside the parentheses and bring around the other set of brackets. So inside the brackets, we still want to simplify this multiplication first. So again, rewrite the problem. 2.5 plus 15. And now we're down to being able to add inside the brackets before we multiply. So 17.5. And our final step is then to multiply these two numbers. You might want to use your calculator to help you with this, but don't let it prevent you from writing down some of the steps in between. So 122.5 should be what we get when we solve this problem. Okay, let's try another example. In this example, you can see that we've specified that x is equal to 3, y is equal to 4, and z is equal to 5. And then in our expression, we've used some variables. So the first thing we have to do is replace or substitute all of the variables with the numbers. So everywhere I see an x, I'll write a 3. Where there's a y, I'll write a 4, and a z, I'll write a 5. So I will replace with, and we'll keep everything else the same. Okay, again I want to start with the innermost parentheses, and so I will simplify the 4 minus 1 right here. Okay, now I'm ready to simplify those in parentheses, so plus 2. I can change to a regular parenthesis instead of a bracket now. Usually you change the bracket or parenthesis or grouping symbol with the more that are included. Okay, now in this problem, a very common mistake that I see, and sometimes if I'm going so fast, my brain wants to do, oh, that's a 5. I want to simplify that 3 plus 2 right away because addition's always easy. But I have to really, really stop myself because I had those grouping symbols, and also because multiplication comes before addition, and that 2 right here on the outside is being multiplied to whatever we simplified inside. So we can't get ahead of ourselves and just say, oh, I can do that real quick and go on, because it's not just always left or right. We have to follow that order of operations. So we get to this step and we'll do 3 plus 4. And we've got our final answer of 7. Okay, we'll do another example. Again, we're going to use some substitution. So x's are equal to 4, y's are equal to 3. So we'll rewrite the problem. And this is a decimal. That's a decimal, 6.5. And we'll substitute in the 3 for the y. And then we'll substitute in the 4. Now in a problem like this, we want to simplify the numerator, then simplify the denominator, and then do the division. So I'll multiply the 6.5 times 3. So I'll get 19.5 plus 2 all over 5. That simplifies to 21.5 by addition. And when I divide, I should get 4.3. So when you have this with a fraction bar, simplify the numerator, simplify the denominator, and do the division last. All right, next up we're going to watch a video with maybe a little bit more complicated order of operations.
Does 3 times 4 to the second power equal 48 or 144? What's your guess? In this lesson, you will learn how to use the order of operations to evaluate expressions by learning the order, then working through examples. Remember, an exponent, or power, tells you how many times to multiply a base number by itself. So 2 raised to the 5th power indicates we are to multiply 2 by itself 5 times. Back to our original question. Does 3 times 4 to the second power equal 48 or 144? Those of you who got 144 probably multiplied this 3 by the 4 to get 12. Then you raise that to the second power by multiplying it by itself and got 144. Those of you who got 48 realized correctly that the only base being raised to the second power is 4. So we should only multiply 4 by itself, not the product of 3 times 4. Since multiplication is the only operation we have left here, we can either multiply 3 by 4 first and get 12 times 4, or we can multiply 4 by 4 first and get 3 times 16. Either way, we're going to get a result of 48. It's important to realize here that because 4 was the only base being raised to the second power, we had to apply the exponent before we multiplied. The only way we would multiply before we applied the exponent would be if the base was written in parentheses as 3 times 4. This would tell us to multiply 3 times 4 first to get 12 as the base of the exponent, and then we'd get 144. But since the original question did not have the multiplication in parentheses, we should not have multiplied 3 by 4 before applying the exponent, so 144 is incorrect. This leads us to see how important it is to complete the operations in the correct order. There were only 2 operations in this expression, yet mixing them up gave us 2 very different answers. For all expressions, the order with which we complete operations is as follows. Parentheses. We complete any operations that are in parentheses first. Exponents. If we see any bases raised to exponents, we apply them now. Again, be sure to apply the exponents only to the bases to which they're attached. Multiplication and division. The next step is to complete any multiplication or division you see. These 2 operations both happen during this step. They are not separate steps. So whichever operation, multiplication or division, that comes first as you go left to right in the expression is the operation you should complete first in this step. Addition and subtraction. The last step you complete is addition and subtraction. As with multiplication and division, these 2 operations both happen at the same time as you travel left to right in the expression. Some people use the acronym PEMDAS to remember the order of operations because the letters of the operations spell this out. P, E, M and D, and then A and S. Others may use the expression, please excuse my dear Aunt Sally, because the letters stand for those words as well. But if you do use a trick to remember the order, please remember to think about it like this. P, then E, then M and D together, then A and S together. If you simply remember PEMDAS, you may think multiplication has to come before division, but they really happen at the same time, so I like to write them like this. Let's try a few examples together. We're going to evaluate 5 minus 4 times 2 to the power of 3. Here's our order of operations. First, let's look for any parentheses. I don't see any, so we'll move on to the exponent step. I do see that 2 is being raised to the third power, and so I'll apply that exponent, and I get 8. Now I'm on to the multiplication and division step. All I see is multiplication, so I'm going to multiply 4 times 8 and get 32. Now I'm on to the addition and subtraction step, and 5 minus 32 is negative 27. So that's our answer. One last example. We want to evaluate 12 divided by 4 minus the quantity 2 plus 7 raised to the second power plus 6 times 3. Quite a mouthful. First we'll look for parentheses. Here they are. We'll apply that 2 plus 7 and get 9. Now we're on to the exponent step. There's an exponent, 9 raised to the second power. That's equal to 81. Now we're on to the multiplication and division step. I see both multiplication and division, but division comes first, so we do it first. 12 divided by 4 is 3. Now we'll go ahead and do the multiplication of 6 times 3 and get 18. Now we're on to the addition and subtraction step. Subtraction comes first. 3 minus 81 is negative 78. Now we'll finally add that to the 18 and get negative 60 as our answer. In this lesson, you've learned how to use the order of operations to evaluate expressions by learning the order, then working through examples.